Hello nature lovers, Bob Ellis here with another episode of Notes from the Field, and we're out here at the Walnut Creek Center for Education and Research, and we are looking for animals. Now, we're not having much luck, and I have a suspicion that this is a story of ecological energetics and what happens when primary production fails. Let's go see if we can find some animals. So we've been walking along for a good bit here, and we're just not seeing a lot of animal sign. We see a little bit of sign. Here's a javelina wallow right over there, where javelinas have worked the soil and rested. And we've seen some butterflies, but there's a disturbing fact that there's no water in this creek, and this creek normally has water in it. And so this is a story, once again, of ecological energetics. And at the very foundation of all biotic communities is the production of biomass. And the way that the ecosystem's productivity is measured is through that production of biomass. And it's called standing crop biomass. That's the measure of an ecosystem's productivity, which simply means how much biomass, that means growing matter, was added to an ecosystem over the course of a particular period of time, let's say a year. Now, in this particular biotic community, we would expect to see a lot of tracks of a number of mammals, including gray fox. We would see some deer, maybe even some coyote tracks, and other mammals that we're familiar with. And we would hear a lot more birds. However, this dry creek bed is absent tracks, with the exception of some javelina tracks, and absent bird sound for the most part. So what we have here are the laws of physics coming home to roost. And since this drought in the Southwest has become so persistent, we're starting to see some effects cascade through the trophic pyramid. Let me show you what I mean by a trophic pyramid. You all might remember this from elementary school, and that is the idea that energy travels through an ecosystem. And all energy starts with the primary producers. And primary producers, I'd like to think for you to think of things that are green. These are plants. For the most part, there are some biotic communities like deep oceanic vents where chemosynthesis takes place at the base of this food trophic pyramid. But for most terrestrial and most aquatic habitats, primary producers are plants. Now, as you all know, there are those organisms that eat the plants. So we call this the first level consumers. And then there is a second level of consumers. And then finally, at the very top, this fourth level, you have the top level predators, or the third level of consumers, tertiary consumers, you might say. So for most biotic communities, you have 3, maybe 4, some maybe 5 levels of the trophic pyramid. That's what we call this. Now, this represents an idea. In reality, the amount of energy that transfers from each one of these levels to another is not graphically represented here. So, primary producers, there's only 10% of the energy produced at this level makes it to this level. Now, you might wonder, well, why is that, Bob? Well, the answer to that is the second law of thermodynamics, which simply states that whenever there is an energy transfer, energy will be lost. And here's the key thing. All energy transfer in biotic communities is inherently inefficient. As low as 2% gets transferred, and in some biotic communities as much as 24% gets transferred. So it's easy for us just to say, on the average, about 10% moves up to the first level of consumers from the producers. Now, what happens at this second level of consumers? Same story. Only 10% of the energy at this level is passed up to this level. So what's an example of this, Bob? Well, we could think of this location out here, primary producers being the plants, and perhaps something like a javelina comes along and eats one of these plants. The javelina is the first level consumer. And then maybe a coyote comes along and is able to capture a young javelina, and then that is that second level of consumers. And then finally, there's the third level, the predators. There's only 10% of the energy that was at this level moves up to this level. So the basic story here is that due to this inefficiency, there is just not a lot of energy available at this top level. So what does that mean for us today in the Southwest, in the Mogollon Highlands? Well, it means this. Whenever this primary production is decreased, that cascades through the whole trophic pyramid. So am I surprised that we don't see a lot of animal tracks in Walnut Creek? Well, brothers and sisters of the Pale Forest, Walnut Creek is dry. And what is at the basis of all primary productivity? Well, we've talked about this before. You need three things. You need temperature, warmer temperature, the higher the productivity. You need moisture and nutrients. If all of those are high, productivity is high. And that productivity moves up the trophic pyramid. So if there's a lot of production at the bottom, you're going to have more organisms as you move up that trophic pyramid. So no water, no productivity, and subsequently no life at the upper end of the trophic pyramid. So maybe you want an example. Well, consider this one. 300 trout would feed a human for 1 year. Those 300 trout would need to eat 90,000 frogs to survive over the course of the year, and those 90,000 frogs would consume 27 million grasshoppers, which would consume 1,000 tons of grass. So the transfer of energy through biotic communities is, by its very nature, as forced by the laws of thermodynamics, inefficient. So maybe some of you are thinking, well, Bob, you're in the Southwest where rivers run underground. Maybe there's water just right upstream. I don't know. Maybe you're right. Why don't we go look? Yeah, as much as I hate to say it, Walnut Creek is dry. There's a saying in ecology, energy flows and matter cycles, and whether we like it or not, we must obey the laws of physics. Limits exceeded are not limits suspended. So energy flows through these biotic communities that originates with that primary productivity, and one of the primary factors of productivity is the presence of water. So I want to thank you all for coming along on this trip. I specifically want to thank the Walnut Creek Center and Nita and her helping us out. And, why don't you go ahead and like this video, subscribe, And if you have ideas for other videos, why don't you just put them in the comments down below. Thanks, and we'll see you later.